Hello, everybody. Welcome back. Today we're going to be looking at subunit 9.7, which is on a topic called coupled reactions. Probably a topic most of you have not covered in Chem 1. So let's get it started. So you're probably getting really tired of hearing me talk again and again and again about what the different signs of delta G, change in Gibbs free energy, what that means. But let's just say one more time, when a delta G value is positive, that means that the reaction is thermodynamically unfavorable. It is not going to happen on its own. It could happen if we help it out in some way. And one of the ways to help out an unfavorable reaction is to do what's called coupling. And what that means is we can take an unfavorable reaction and couple it or link it with a reaction that is thermodynamically favorable in order to make the overall process favorable. Now, can you take any favorable reaction and link it to the unfavorable one? No, it can't just be any reaction. The two reactions involved need to have an intermediate in common. Now let's review that term back from the kinetics unit. An intermediate, we saw that word when we learned about reaction mechanisms and elementary steps. An intermediate was a product of one reaction that becomes consumed as a reactant in a subsequent step. So if two reactions have an intermediate in common, then they may be able to be coupled. And the situation that we're typically going to be presented with these coupling problems is in the context of a Hess's law problem, which we have seen a couple of times now. We saw it first in the thermochemistry unit, unit 6. We saw it again in equilibrium, where we have multiple reactions and we end up adding them together. So let's look at an example. Okay, so at the top of the screen, I want you to look at these two reactions, the first one in particular. Okay, and I want you to notice that the first reaction has a positive delta G value, indicating that that first reaction is not favorable. Whereas the second reaction does have a favorable delta G, it's negative. I also want you to notice that these two reactions have an intermediate in common. Oxygen is produced in the first reaction and is consumed as a reactant in the second one. So this looks like a good situation for coupling. And the question says, calculate delta G for this reaction. And we have done this before. This is a Hess's law situation. Let's review the thought process in a Hess's law problem. Okay, so we'll start with Fe2O3. I can see that it's in this first reaction. It's on the correct side. It is a reactant, and it has the correct coefficient. So I don't need to adjust that first reaction in any way. I don't need to multiply it or flip it around, anything like that. So this first reaction looks good the way it is. Let's come here. 3 carbon monoxides. Well, I've got carbon monoxide here, but it does not have the correct coefficient. So remember, I'm going to need to multiply this whole equation and its delta G value times 3 to get those coefficients to work out. So I'm just going to rewrite that second equation multiplied by 3 now. And its new delta G value is negative 850.5 kilojoules. Okay. And what I'm going to do as well is I'm going to now scribble out this one so we don't get confused. Okay. And remember, the process now is I'm going to add these two equations together. All right, and I can see now that those 3 halves O2 are going to cancel out. Is there anything else we can cancel out? Doesn't look like it. And that is going to leave me with the overall reaction that I wanted. And when we add those delta G values together, overall I get negative 108.3 kilojoules. So here's the take-home message here. I had one equation that was unfavorable, positive delta G, another equation that was favorable, negative delta G. They had an intermediate in common, and so I was able to couple them, put them together, and you can see that when I did that, I get an overall negative delta G value, which indicates that the overall process is favorable. So this worked out perfectly for us. And that's what coupling is all about. These reactions share an intermediate, and when they are put together, when they are coupled, yielded an overall reaction with a negative delta G. Okay? So I want you guys to try this one on your own. It's essentially the same thing. Okay? So pause your video, try this one. Okay, so this one was actually even easier than the previous question because I did not have to adjust either one of the given reactions. I didn't have to flip any of them. I didn't have to multiply. They were ready to be added together as is. I could see that intermediate sulfur gets canceled out. I end up with the overall reaction that I was supposed to. And when I add the delta G's together, I get negative 101.8 kilojoules, which is overall negative. Okay. And then part B says explain why these given reactions represented are suitable for coupling. Remember, not every situation is the best for coupling, but why is this suitable to give us a thermodynamically favored process? And I just simply said these reactions share an intermediate, and when they are coupled, they give us a delta G that is negative. So this was a pretty short one today. I hope you all have learned a little something today about coupling, and I look forward to seeing you next time.